general solutions of standard T equations. T is nothing but the trigonometric equations. Earlier we have seen the solutions for simple T equations. Now we're going to see the solution for standard T equations. So let's see what are those. The first equation is sine theta is equal to sine alpha. Then for these kind of equations, the general solution will be theta is equal to n pi plus minus 1 whole power n into alpha, where alpha belongs to minus pi by 2 to pi by 2 and n belongs to all the integers. So let's prove this, and let's also discuss why alpha only belongs to this range, not all the values. Let's see how it goes. So first let's derive this. So the proof here is, now this equation can be written as sine theta minus sine alpha is equal to 0. Just apply the sine C minus sine D formula. What is the formula for sine C minus sine D? This can be written as 2 times of sine C minus D by 2 into cos times C plus D by 2. Instead of C and D, you can also keep X and Y. It's the same thing. So let's use this formula over here. It becomes sine 2 times of sine theta minus alpha by 2 into cos theta plus alpha by 2. This becomes 0. When it will become 0? Only when sine theta minus alpha by 2 is 0, or one more condition, cos theta plus alpha by 2. So these are the two conditions only when this equation will be 0. So for this, we have seen the solutions, right? So this is the simple trigonometric equation. So earlier we have seen sine theta equal to 0. Then the solution for theta will be n pi, where n belongs to integers. And we have also seen cos. Cos theta will be 0. Then theta will be 2n plus 1 times of pi by 2, where n belongs to integers. So just use these simple two equations over here. So instead of theta over here, it will be theta minus alpha by 2. So it becomes theta minus alpha by 2 is nothing but this n pi. N pi. From here, theta can be written as 2n pi plus alpha, again where n belongs to all the integers. Or use the cos theta simple equation, that is theta plus alpha by 2 will be 2n plus 1 times of pi by 2, that is this. When you take theta over here, it becomes 2n plus 1 times of pi minus alpha, where n belongs to all the integers. So just combine these two solutions. If you observe properly over here, 2n pi is all the even multiples of pi. 2n plus 1 times of pi is all the odd multiples of pi. So when we combine these two equations, these two solutions, the theta will be, it includes all the even multiple and it includes all the odd multiple. So we can write it as n pi. N is any integer. It might be an even integer or it might be an odd one. So from these two we can write n pi. Next, it is plus alpha and it is minus alpha. So can we write plus or minus alpha? Is this correct? If you want, you can check. Like for example, keep any integers like n instead of n, keep 0, 1, -1. You can verify it. It won't give you right solutions. Why? Because it is plus alpha when it is an even multiple of pi. When it, when it is an even multiple of pi, it is plus alpha. When it is an odd multiple of pi, it is minus alpha. So here we should write that plus -1 whole power n alpha, where n belongs to all integers. You can also check. Keep n as 1. If you keep n as 1, theta will be pi and odd power will be minus alpha. It's the same thing, right? It for odd multiple of pi, it is minus. Keep n equal to 2. It becomes 2 pi -1 whole square. It becomes plus. So for the odd multiple, it is minus. For even multiple, it is plus. So this equation holds true. That only we have written over here, that is theta equal to n pi plus -1 whole power n into alpha, and n belongs to all integers. What is this? Alpha is equal to minus pi by 2 to pi by 2. Why this is range given? Because if you see the sin x graph, it is something like this, right? So minus pi by 2 is something over here, and plus pi by 2 is something over here. So from here, if you write sin alpha, then sin alpha belongs to -1 to 1, because sin of minus pi by 2 is -1, sin of pi by 2 is 1. So that's what we want, right? Here will be -1. From here, it will be +1. So all the values of sin are included in this range. So, so if you considered alpha from here, you can get any value of sin because it is bounded between 1 and -1. And to get a exact solution, you should use this range. So that's the reason we have written alpha is equal to, alpha belongs to closed minus pi by 2 to open pi by 2. In this question, it is given that find the general solution of sin x is equal to 1 by root 2. So how to write this? First write the equation, that is sin x is equal to 1 by root 2 can be written as sine of pi by 4. So now it's in the format of, now this is in the format of sine theta is equal to sine alpha. Just now we have seen the general solution of theta will be n pi plus -1 whole power n alpha, where n belongs to integers and alpha belongs to minus pi by 2 to pi by 2. So this pi by 4 holds true for alpha because it lies in the range, right? So now this solution can be written as x is equal to, here theta is nothing but here x, right? It becomes n pi plus -1 whole power n pi by 4, because their alpha is nothing but pi by 4. So this is the required general solution for sin x is equal to 1 by root 2. Next example, find the general solution of sin x is equal to minus of root 3 by 2. Now this can be written as sin x is equal to minus sine root 3 by 2 is nothing but pi by 3. Minus of sine pi by 3. But we didn't But we don't know the general solution because negative sign is there. But if you remember the basic trigonometry, we can write this as this sine pi by 3 can be written as sine of pi plus pi by 3, right? Why? Because if you consider this four quadrants, sine is plus over here, negative and negative. So here it is minus sign. So it can be written as pi plus pi by 3 because here it is negative. Sign is negative. So from here we can write sin x is equal to sine of pi plus pi by 3 is nothing but 4 pi by 3. Now use this solution, this general solution. That is because it is in the form of sine theta equal to sine alpha. Therefore, x can be written as n pi plus minus 1 whole power n 4 pi by 3, where n belongs to all the integers. Now you can also get a doubt. Here, instead of pi plus pi by 3, we can also take 2 pi, pi, 2 pi minus pi by 3, right? Because there also the sign will be negative. Yes, you can also take that, but the final answers will remain the same. Only the solution might here changes, but all the values of x will remain the same.
Next standard T equation is cos theta is equal to cos alpha. For this, the general solution of theta is 2n pi plus or minus alpha, where n belongs to all the integers and alpha lies in the range closed 0 to pi. So let's prove this. So you can write it as cos theta minus cos alpha is 0. So you can use the formula cos C minus cos D, which is nothing but minus 2 times of sine C plus D by 2 into sine C minus D by 2.
Use this formula over here, it becomes minus 2 times of sine. C is nothing but theta over here and D is nothing but alpha. Theta plus alpha by 2 and sine theta minus alpha by 2, which is equal to 0. So when this equation will be 0, whenever sine theta plus alpha by 2 is 0, or the other condition is sine theta minus alpha by 2 is 0. So it's now this equation is nothing but simple trigonometric equation, that is sine theta equal to 0, which we can write it as theta will be n pi, where n belongs to all the integers. So if we use that simple solution, we can write this as theta plus alpha by 2 will be equal to n pi, where n belongs to all integers. Therefore, theta can be 2n pi minus alpha, where n belongs to all the integers. Similarly, here we can write the same thing. Theta minus alpha by 2 is equal to n pi. Therefore, theta will be 2n pi plus alpha, and L belongs to all the integers. So if we combine these two solutions, we can write the final solution of theta, that is here also the 2n pi is there and here also 2n pi is there. So we can write in the final solution 2n pi, and here it is minus alpha and here it is plus alpha. So can we write plus or minus alpha? Is this correct? Yes, because for the even multiple here, it is minus alpha, and for the even multiple of pi, it is also plus alpha. So in the final solution for the even multiple, we can write plus or minus alpha, and n belongs to all the integers. So that's the reason, that's what we have written here. That is, theta is n equal to 2n pi plus or minus alpha, n belongs to I. Why this alpha belongs to close 0 comma pi? Because from here, if we write cos on both sides, it becomes cos alpha belongs to cos 0 is 1, cos pi is minus 1. So this is true, right? If we think about the cos x graph, it will be like this, something like this. So the highest value will be 1 and the least value will also be minus 1. So cos is lying in the range. So it belongs to alpha belongs to 0 comma pi. In this question, we need to find the general solution of this equation, that is cos x is equal to half. Half can be written as cos pi by 3 or pi by 6. Pi by 3 is nothing but 60 degrees. So from the general solution, so this is in the form of cos theta is equal to cos alpha. So we know we have just derived it, that is theta is equal to 2n pi plus or minus alpha, and n belongs to all the integers, and alpha also is lying between the range 0 comma pi, because pi by 3 lies in that range, right? So we can write the solution for this, that is x will be 2n pi plus or minus pi by 3, where n belongs to all the integers. So this is the general solution of cos x is equal to half. Here we need to find the general solution of secant x is equal to 2 by root 3. Now you can get it down. Didi, we have didn't discuss the secant x general solution, but how to find out here? But we know the relation between secant x and cos x, right? We can write it as 1 by cos x is equal to 2 by root 3. Isn't it correct? Yes. So from here you can write it as cos x is equal to root 3 by 2. From here, root 3 by 2 is nothing but cos pi by 6, that is cos 30 degrees. Now it's similar to again this value, that is cos theta equal to cos alpha, and theta can be written as like this. So now the general solution will be x is equal to 2n pi plus or minus pi by 6, and n belongs to all the integers. In this question, we need to find the general solution of cos theta is equal to cos 3x. Now, if you carefully observe this is in the form of directly. This is directly in the form of cos theta is equal to cos alpha. But alpha here is nothing but 3x. So, so for this, what's the solution? We'll write theta as 2n pi plus or minus alpha. So similarly, for this, the solution will be theta will be 2n pi plus or minus 3x, because alpha is nothing but 3x and n belongs to all the integers. Next trigonometric equation is tan theta equal to tan alpha. For this, the general solution of theta will be theta is equal to n pi plus alpha, where n belongs to all the integers and alpha belongs to open minus pi by 2 to plus pi by 2, that is also open, which is not included. So let's prove this. Now this also we can write it as tan theta minus tan alpha, which is equal to 0. Tan is nothing but sine by cos. So sine theta by cos theta. Again, this is also sine alpha by cos alpha, which is 0. And just take LCM over here. We can write sine theta into cos alpha minus sine alpha into cos theta by cos theta cos alpha equal to 0. We can write it as sine theta cos alpha minus sine alpha cos theta equal to 0. Now, if you carefully observe, this equation is in the form of sin x cos y minus cos x sin y is equal to 0. This can be written as sine of x minus y is 0. So just write it over here, which becomes sine of theta minus alpha is 0. So again, this equation is in the form of sine theta is 0. This is the simple equation we have seen, and we also know the solution for this, that is theta will be n pi, where n belongs to all the integers. So similarly, you can write it over here, that is theta minus alpha becomes n pi. Therefore, theta will be n pi plus alpha, where n belongs to all the integers. So this is what the final solution is. And we have also got it over here, that is theta equal to n pi plus alpha, and n belongs to all the integers. And why alpha belongs to this? Because if you see the tan x graph, it will be something like this. This is if it is pi by 2, and this is minus pi by 2. It will be something like this, right? Because it doesn't touch this. So that's the reason here it is open. Matlab it is not included because tan pi by 2 is undefined, not defined. So that's the reason it is, these values are not included in this. So in this question, we need to find the general solution of tan x is equal to root 3. So this can be written as tan x is equal to tan 60 or 30 degrees. Tan 60, 60 in the sense pi by 3. So it's in the form of tan theta is equal to tan alpha. And we have just seen the solution for this general solution, that is theta is equal to n pi plus alpha, where n belongs to all the integers. So just write the solution for the same. It becomes x is equal to n pi plus pi by 3, where n belongs to all the integers. And here pi by 3 also lies between minus pi by 2 to pi by 2. In this question, we need to find the general solution of cot x is equal to minus under root 3. So let's convert into tan x because we know the general solution for tan. So it becomes 1 by tan x is equal to minus under root 3, and tan x will be minus 1 by root 3. From here we can write minus tan pi by 6. Is it true? So to clear this negative sign, what shall we write? If you see the four coordinates, tan will be plus over here, minus over here, plus over here, and minus over here. So it is minus. We can write pi minus pi by 6, right? So it becomes tan of pi minus pi by 6. I hope you guys, I hope these all things you know before, because these are the basic trigonometry we learned before the equations. So it becomes tan x is equal to tan of pi minus pi by 6, that is 5 pi by 6. Now this is in the form of tan theta is equal to tan alpha, and we can write the general solution of theta. That is, here it's x, it becomes n pi plus 5 pi by 6, and n belongs to I, and this 5 pi by 6 also lies in the range, that is open minus pi by 2 to pi by 2. The next standard T equation is cos square theta is equal to cos square alpha. Here the general solution of theta will be again n pi plus or minus alpha, where n belongs to the all integers. So let's prove this. We know the general identity, the basic identity for sine and cos is sine square theta plus cos square theta is 1. From here we can write cos square theta as 1 minus sine square theta. So if you use this thing over here, we can write it as cos square theta is nothing but 1 minus sine square theta. Cos square alpha is nothing but 1 minus sine square alpha. If you cancel 1 and 1, minus and minus, you will get, that is sine square theta is equal to sine square alpha. So just now we have proved the general solution for these kind of equations, that is theta is equal to n pi plus or minus alpha, where n belongs to the integers. That's the reason it this equation also has the same solution as of sine square theta is equal to sine square alpha. So let's see an example. In this question, we need to find the general solution for this equation. Okay, let's do this. So we can write this as cos square theta x plus pi by 3 as it is. Here we need to write sine in terms of cos. We also have a chance that we can write it as 1 minus cos square something. But if we write like this, we can't use the general solutions what we have discussed earlier, right? So instead of this, we gonna write it like this. That is cos square pi by 2 minus of pi by 3 minus x. Why? Because we are using the complementary angles. That is cos of pi by 2 minus theta. Assume this as theta. So cos of pi by 2 minus theta will be sine theta. So that's the reason we are writing this expression of sine in terms of cos. So if we compare with the equation, that is cos square theta is equal to cos square alpha, then the solution will be theta is equal to n pi plus or minus alpha, where n belongs to all the integers. So here this is nothing but theta, forget about this, and this is nothing but alpha. So the general solution will be x plus pi by 3 is equal to n pi plus or minus this whole thing. Pi by 2 minus pi by 3 is nothing but pi by 6, and minus into minus plus x. So here again two cases will be case 1, that is x plus pi by 3 will be n pi plus pi by 6 plus x, and the case 2 will be x plus pi by 3. Use the minus over here. If you use minus, it becomes minus pi by 6 and minus x. So in this situation, here the x and x are getting cancelled. So for what we need to find the solution? So these kind of cases we need to ignore. Just leave this. So here use the case 2. Now if you send x this side, it becomes 2x and pi, and minus pi by 6 minus pi by 3, which is nothing but minus pi by 2. And therefore we can write x as n pi by 2 minus pi by 4. So this is the general solution for this equation. And here obviously n belongs to all the integers. Next standard trigonometric equation is sine square theta is equal to sine square. Next standard trigonometric equation is sine square theta is equal to sine square alpha. For this, the general solution of theta will be n pi plus or minus alpha, where n belongs to all the integers. So let's prove this. So we can write this as sine square theta minus sine square alpha is 0. So if you remember the formula, that is sine square x minus sine square y can be written as sine of x plus y into sine of x minus y. So from this formula, we can write it as sine of theta plus alpha into sine of theta minus alpha will be 0. So if we take case 1, that is sine of theta plus alpha might be 0, or case 2, that is sine of theta minus alpha might be 0. So now this is in the form of sine theta equal to 0. From here we can write the solution of theta is n pi, where n belongs to all the integers. So just write it over here, that is theta plus alpha equal to n pi, and from here theta becomes n pi minus alpha, where n belongs to all the integers. Similarly, here theta minus alpha, similarly here theta minus alpha will be n pi. Therefore, theta can be written as n pi plus alpha, and n belongs to all the integers. If you write a common solution from these two solutions, you can write it as theta will be, here also there is an n pi, here also there is an n pi. So we can write it as n pi over here, and here it is minus alpha, here it is plus alpha. So directly we can write it as plus or minus alpha, and n belongs to all the integers. So that's the solution. Here it is, that is theta is equal to n pi plus or minus alpha, and n belongs to all the integers. The last but not the least, the standard T equation is tan square theta is equal to tan square alpha. Here the general solution for theta will be n pi plus or minus alpha, where n belongs to all the integers. Let's see what is the proof for this. Now this tan can be written as secant square theta minus 1 and secant square alpha minus 1, because we know the identity, that is secant square theta can be written as 1 plus tan square theta. So here tan square theta can be written as secant square theta minus 1. So if you cancel minus 1 and minus 1, you will get secant square. Now write secant in terms of cos. We'll write it as 1 by cos square theta, 1 by cos square alpha. Again, this can be written as cos square theta is equal to cos square alpha. I mean, cr- cr- if you cross multiply it. Now again, just now we have seen the cos square theta is equal to cos square alpha is nothing but sine square theta is equal to sine square alpha. We know the general solution for this, that is theta is equal to n pi plus or minus alpha, where n belongs to the all integers. So that's the reason we have the general solution for tan, that is theta is equal to n pi plus or minus alpha, and n belongs to all the integers. Now let's recap all the results what we got till now for the general solution of standard equation. First, that is sine theta is equal to sine alpha. Here, here the general solution for theta is n pi plus minus 1 whole power n alpha, where n belongs to all the integers and alpha belongs to closed minus pi by 2 to plus pi by 2. Next, cos theta is equal to cos alpha. Here, the general solution of theta is 2n pi plus or minus alpha, where n belongs to all the integers and alpha belongs to closed 0 comma pi. Third, tan theta is equal to tan alpha. Here, the general solution of theta is n pi plus alpha, where n belongs to all the integers but alpha belongs to open minus pi by 2 to open plus pi by 2, which means minus pi by 2 and pi by 2 are not included. Fourth, sine square theta is equal to sine square alpha. And for fifth and sixth, the same general solution exists, that is theta is equal to n pi plus or minus alpha, where n belongs to all the integers.